So, the z, notice, z to the 20th, z was an even, or 20 was an even or an odd number. That was even. Okay, actually, 36 here had an absolute value on it. That was even. It was even on the inside. It came out odd. Okay, this one, the y cubed up here, y to the 6th was even, came out odd. Okay, because if it's an odd number, if that's x to the 5th, if that's an odd number, you take a negative number to the 5th power, isn't it going to be negative already?
Yes.
It's only positive numbers that turn out they should be negative that are a problem. So we call this, I call this anyhow, you won't find this in a book, I call this the even-odd rule. This is when you add absolute value. Okay, if it hits the even-odd rule, okay? The first even stands for you had to have had an even index. It had to be a square root, a 4th root, a 6th root, a 10th root, a 200th root. Had to be an even index on the outside when you started. It had to be an even power on the inside of the roots when you started. And it had to turn out an odd power once you had it outside the root. So I will take you through several of those to make that distinct here. So on this problem we just did, we had a cube root. Did we have an even index to start with? No. We had an odd, so there's no absolute value for sure here. Immediately. If it's an odd root, 3rd root, 5th root, 10th, or 11th root, you'll never have an absolute value. So that one we would not even sweat it. Notice up here on our x to the 5th in the square root, you had an even power, an even index. What was your power on the inside? It was odd, so no absolute value. Well, let's go back to one of these that did have an absolute value. Down here at the bottom, you had a 12th root. That's even. The 36 on the inside came out odd. That's when you absolute value it. Wow. You have to have all three things before you absolute value it. So actually the absolute values are fairly rare. So let us try something here. Suppose I give you the 4th root of f to the 21st, that's supposed to be an f, g to the 30th, h to the 16th. Okay, and I want you to break that down. First of all, break down the powers. Don't worry about the absolute value till the very end. 4 goes into 21. How many times? 5. What's your remainder? 1. Okay, make sure you keep that a 4th root over there. Okay, 4 goes into 30 how many times? 7. 4 times 7 would be 28, so that means I have a remainder of 2. Okay, 4 goes into 16. 4 to 16 divided by 4 is even, so I don't have any remainder on the inside of the root. Okay, then go back and check the even, odd. Did you start with an even index? Yep. Okay. Were any of these inside even? Yes. G and H were even. So of those two, did either of them turn out odd? Just the G? G turned out odd, so only the G gets absolute value. Actually, we would prefer to write that then, since the G is absolute valued, they'd probably write it f to the 5th, h to the 4th, absolute value of G. Thank you, to the 7th, with the 4th root of f g squared. So put the absolute value clear to the front or clear to the back. Okay, do a simpler, the one that doesn't what now? Okay, well, I'm going to kill 2 birds with 1 stone here. What if I tell you to multiply them? It's nothing. Be cool. It's okay. First of all, multiply them. Yesterday's rules, exponent rules. What do you get when you multiply the x's? X to the first times X to the third makes X to the fourth. That's no big deal. Y to the 10th. Okay. Get them combined. Now break them down. 4 goes into 4 one time. So I have X to the first on the outside period. No remainder. 4 goes into 10 twice with a remainder of 2. And this is a fourth root. Okay, now you have to go back and check for absolute value. Okay, and here's the main thing. If it was a it has to be the original problem. So where both indexes even. Yes. Okay, where both X is even. Nope. Were both Y's even? Yes. Did the Y's come out odd? No. So do I need an absolute value? No, because none of it met the whole even, odd deal. It's got to be all of them meet even, odd before you ever absolute value it. You do have to, if there's two separate ones multiplied, you got to check both originals, not the multiplied version. Because this would make you think, yeah, I was even, but Y still didn't come out odd, so it didn't happen for us. X would have, yes. Yeah, it looks like the X would have been even, came out X the first. You'd think that one happened, but because the original problems, original X's weren't even, you don't have to sweat it. So, yes, they both would have to be even before you'd even worry about it. Yay, team? Okay, that's your fun and exciting root worksheet.
Wait, do we have another one?
We have two.
The other one is graphing. You actually know half of this already. You do. This is not bad.
Wait, are we using this sheet to take notes?
Yeah, you can. If you took an extra sheet of graph paper to take notes, then yes, here are your notes coming.
We only got one.
I sent the whole stack around. You're supposed to grab another. Did it get stalled somewhere? Did it not?
Whole row got like 5 sheets.
Oh. Okay, children. You realize all that's getting recorded.
My hair stops, everyone.
Okay. All right. I'm only teaching you basic graphs here. Since this chapter is about exponents and roots, guess what we're going to graph? Exponents and roots. Okay. All the rules you've already learned about how graphs shift around and flip over, same rules still apply. In fact, the first graph we're going to do is one you already know and love. I'm only going to teach you how to graph x squared, x cubed, square root, and cube root. Okay, so this is x squared. You guys already know x squared. What is the graph of x squared shape? It's a parabola. And you already learned the fun t-table of values that create a parabola. Well, how do you get the y coordinates on a parabola? Since it's x squared, you square them. So you square all those numbers. You remember the many, many times you graphed 149? Okay. So since we know this is a parabola, we know it's going to be 0, 0, 1, 1 on both sides, 2, 4 on both sides, and 3, 9. 6, 7, 8, 9 on both sides. And we will have a joyously happy parabola. That is, it is. Parabolas are a snap now. You guys should be expert parabola people.
What? Oh, snap. I thought it was like
A snap. Okay. Now, the new one you get to learn is what does x cubed look like. Okay. We get it the same way. You're going to do yourself a little short t-table. Now, because we're cubing the numbers get big pretty quick. So, I'm only going to have you graph 0, 1, and 2. Because now you're cubing them. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Why do I not want you to do 3? 27. Do you really want to count 27 boxes?
I don't know how to count that.
So we won't be counting 27 boxes. We're just going to do 0, 1, and 2. So consequently, yeah, we got 0, 0, 1, 1, and 2 over 8 up. 1, 2, 3, 4, 5, 6, 7, 8. But here's where the difference happens. This one is not a parabola. Because when you go over to the negative side, what happens when you cube a negative 1? If you hit negative 1 times itself 3 times, you get, no it's not. Negative 2 cubed is negative 8. So it's the exact same point, except, yeah. So you're going to go left 1, down 1, left 2, down 8. 3, 4, 5, 6, 7, 8 is going to be about right there. And so, I get squiggly line. Ah, yes, it is a squiggly line. Thank you for saying that. You just played into my exact name for it.
Oh, good job.
Hey. Many moons back, somewhere in the early 90s, mathematically, this graph does not have a name. Like, that's a parabola. This one doesn't have a name. So they decided we needed to name it. And ever since we've named it, I don't have trouble with people remembering it anymore. And they looked exactly what you said. Well, it's kind of a squiggly line, but they said it's got to sound like the parabola, hyperbola type sound. So they named it the Scrabola. The Scrabola. So take the squiggle and then put Scrabola on it. So
Is that an official name or can we change the name?
That's the official NV name. It works though because I never have trouble. People know a Scrabble every time. But don't go tell a college professor it's a Scrabble, because they're going to think you're a lunatic. Because it's only been named here at NV as Scrabble. No one else calls it a Scrabble. We call it a Scrabble.
We named it.
Yeah. But it works.
I thought you said some professor stuff. Yeah.
No, my students thought we needed to
Oh, that makes it much.
So,
How long did it take you to come up with that?
30 seconds.
No.
So,
We should make it better.
it's a Scrabble.
Good as well.
It works. It's worked for years. I like my Scrabbles. Thank you very much. Okay. So, that's basic X cubed. The other two graphs you're going to learn to draw are the roots of those same exact graphs. And I need some more, actually I don't need yellow space, I could write. No, you want yellow space. And this is the amazing cool part. I want you to graph square root of x. Okay. Square root of x is what you get when you do the inverse of x squared. When you switch x and y and you solve for y like we just did with our inverses before Christmas, you get square roots. So, if you want to graph a square root, it switches the x and y coordinates on a parabola, on an x squared. So all you have to do is switch those coordinates. You put the 0, 1, 2, 3 down the right side, and you put the 0, 1, 4, 9 on the left side. They're inverses. They switch their x and y coordinates. That's all they do. So now, when you plot it, the 0, 0, the 1, 1, that's pretty boring. But now it's over 4, up 2. So 4 to the right, up 2. 9 to the right, 5, 6, 7, 8, 9 to the right, up 3. So it's going off, what is it?
A really wide V.
It's half of something.
Half a parabola.
It's half a sideways parabola, yeah.
Ooh.
Now, why am I not going to do the mirror points down here?
Is that too much work?
Nope. Well, would it pass the vertical line test?
No.
It wouldn't be a function if I do that.
No.
So, square roots only are a sideways half parabola. If I put a plus or minus on the square root, then you would have the bottom piece. But for the most part, no. When it says graph a square root, you are not going to do the bottom piece, because we aren't graphing plus or minus ones. So a square root is just half a sideways parabola. Okay, so then, what do you suppose that means I have to do to get a cube root? Reverse what? I reverse these same coordinates I did up here. I put the 0, 1, 2 down the right side, and I put the cube numbers down the left side. So I'll get, have you noticed 0, 0, and 1, 1 are in just about everything we ever do? 2, 3, 4, 5, 6, 7. Now I'm going over 8, up 2. Now, on this one, what's going to happen when I do negatives? Negatives will go down. Negative 1, and then negative 8, negative 2. And so it's a sideways parabola. So they're related. They're connected. X squared is a parabola, square root is a sideways parabola. X cubed is a parabola, cube root is a sideways parabola. So if you know one, you know them both. You just have to switch your coordinates. That's all it takes. Thing of beauty.
Kind of like looking through a weird game here.
Come on, go, dude. I'm running out of time. I have to show them how, remind them how to shift. Okay, I need to shift one graph. Which one do you want to shift?
I want to do the first scramble.
A vertical scramble? You aren't going, dude. You cannot lock up on me now. There it goes. Okay. No. It's going sluggish on me. Okay. All right. DJ requested. Ooh, not that far. That would run me off my graph paper. Well, good one. All right. DJ requested here. You have to, when you look at one of these, you have to go look. Oh, it's a cube. No, you can't talk to us.
Attention students, tomorrow there will be no DEX program. Tomorrow in the morning there will be no DEX program.
I knew that before everybody else did.
Which shape is this? Square root? Is it? This is a vertical scrabbler. Okay, it's not drawn well. Where does it shift to? You already know these rules. We changed x to x plus 4. So that is left 4. The number on the outside, you change the sign or not? That is down 1. Okay, the only other thing you need to know is, what do you do with that 2 in front? Multiply it times which coordinate? Always the y coordinates. You always multiply the number out front times the y coordinates. So that'll become 2 and that'll become 16.
Wonderful.
Enjoy. Do this. Practice.
Oh my goodness.